Start recording. There we go. Good morning. This is Thursday, October 17th, 2013. This is the first period of geometry class at Washington State School for the Blind. I will introduce myself and then the students will introduce themselves. We only have 3 other students today. I am J.J. Isaacson, instructor.
Abby Griffith, Jessica.
Bryant, go ahead.
I'm Bryant Walker.
All right. And Stormy?
I'm Stormy Stone.
All right. And we're going to be working on some homework questions today from page 113. And then we're going to launch into section 3-5, which is in volume 9 of Braille on page 116. And in print, obviously, on page 116. If you don't have the book with you, you certainly can just follow along and listen to what we're doing here. All right. Homework questions. Homework, guys. All right. So you had to figure out whether something was an adjacent angle, linear pair, or neither. And it could be both of them also, right? It could be adjacent and linear. So number 8, you have angle 1 and 2 in this drawing. It looks sort of like a right angle. It's not quite because it doesn't have the little box, but they do have angle 2 at the bottom of the big angle and then angle 1 just above it. So are those angles, angle 1 and 2, are they adjacent, linear, or neither? Adjacent. Now, thinking to your definition of adjacent angles, be a Euclidean geometrist and say why or prove why those are adjacent angles. Why are they adjacent?
Because they share that side.
They share a common side. Abby's pointing at that side and she's putting her fingers along the common ray. Okay, they share a common side. And what else do they have to share?
Count that, do we?
We don't count those. No. Yes, Stormy and Abby, they share a common vertex. And that's the 2 criteria to be an adjacent pair or an adjacent angles is that they share a common side and they share the vertex, common vertex. All right, number 9. Stormy, you want to take this one? Number 9 is at the bottom of page C113.
Linear.
Okay, that's close. You would think that there could be a possibility of linear angles, but actually the angle number 1 is to the left and it has 2 rays making it. Then you go over and take a look at angle number 2. It's on the right and it has 2 separate rays. They don't share a common ray. They're split by that angle in the middle.
Oh, okay.
Yeah, they're split. Well, the 3 angles together create linear, but it's not a pair. A pair means 2. It didn't say a linear trio, right? So angle 1 on the left and angle 2 on the right, they're split up by that angle in the middle, that big angle in the middle. See that big? Yes.
What should we say that one?
You say neither. Neither.
Yeah, because
they share the vertex, okay, but they don't share a common side. And then it is trickery because we do have those 2 opposite rays creating that line. So we're set up to think, oh, we could have a linear pair here, but really we don't because the line. Don't always assume, that a line means that they're linear because you've got 3 angles on here, and they're not a pair. They're opposing each other. All right, that's how you learn this. Okay, Bryant, if you would turn the page to D113, there's a tactile right at the top of the page.
Mm-hmm.
And we've got some lines crisscrossing up there. And there are 2 angles that they are labeling. The bottom of the line that goes from about 8 o'clock to 2 o'clock. There's 2 angles created by the ray extending from the bottom of it, angle 1 and angle 2. So are these angles adjacent, linear, neither, both?
Linear.
Okay, they're linear, yes, because they're side by side and they create this long line. They're non-common ray or opposite rays. They share a vertex. They have a common ray. So if they're linear, then what are they also?
Adjacent.
Adjacent, yes. A linear pair is always adjacent. Adjacent pairs are not always linear, but a linear pair is always adjacent.
How come you adjacent? Because that one goes with that. They don't
Correct.
share.
But this angle shares that vertex with this angle. See? So they share a vertex. They share a common ray. They also create a line. So we have angle 1 and angle 2 on this line, this linear pair. So they're adjacent and linear. So Abby, listen again to my words. Linear pairs are always adjacent because they always share a vertex and a common ray. Okay? So if it's a linear pair, it's also adjacent. All right? Adjacent angles are not always linear. We could have two. We could have a 20-degree angle and those two right there. Right, but they don't form a line, correct. But a linear pair will always be adjacent. All right? Okay. All right. Back to you, Abby. We're on number 11 at the bottom of page D113. All right, we have several rays going on here. 1, 2, 3, 4, 5 rays. Sharing a vertex, so that's meeting a criteria already, isn't it? Then you got to find angle 1 and angle 2. Looks like angle 1 has that second ray and third ray from the left, and angle 2 has that third and fourth ray from the left. So are these adjacent, linear, neither, both?
Both.
They're both adjacent and linear? Now you're getting fooled again by that line.
No, that's not adjacent.
No, those two little angles there, they're
own.
only next to each other, aren't they? They don't make the whole line. See, what makes the whole line, Abby, is this angle, this angle, this angle, and this angle. Okay? That's what makes the whole line. But these two angles right here that they're indicating, these two in the middle, those do not make the line. They only make this angle together, combined together. Okay? Right?
Just a linear?
No, it's not linear.
Yeah, they create.
There's a... Well, okay. So let's listen to the words again. Now, an adjacent pair has to share a vertex and a common ray. A linear pair has to share a vertex, a common ray, and their non-common sides go in opposite directions and create a line. So this set of angles, they share a vertex, right? They share a common ray. Now take a look at their non-common sides. Do those make a line? No. So they're just an adjacent pair, right? Okay?
You don't look at it.
Correct. Do not look at that unless it's just two. You got sucked into that again. All right. All right, Miss Stormy. How about number 12? That's on the next Braille page, E113. Got two lines intersecting on number 12.
I put linear.
You put linear for number 12? All right, let's take a look at it. That's incorrect. All right, so if we're looking at these two lines, it forms a big X, a printed X in the middle of our page, right? And two lines you learned a long time ago, if two lines intersect, they intersect at what?
The point?
A point. So there's our point right in the middle. That's our vertex, isn't it?
Yeah.
Okay, so from our vertex right in the middle, let's pretend like we're at a clock. We're going to follow our ray up till about the 11 o'clock position. There's one ray, 11 o'clock. Go back to your vertex and follow the ray up to about the 2 o'clock position or 1 o'clock position. All right, so about 10 and 2, really. Now, those two rays coming together at that vertex, that forms an angle that they've labeled angle 1 just above it. That's an angle. Okay, now go back to your vertex and follow your ray down till about 8 o'clock. And then go back to your vertex and follow your ray down till about 4 o'clock. So those two rays, that forms an angle that they've labeled in the middle angle 2. Now, what is the definition of adjacent angles? They have to share a vertex. Do they share a vertex? Yes. Then they also have to share what?
A common
ray. Do they share a common ray?
Yeah,
They share a common ray?
No. No, look.
Go to the vertex, and the angle 1 has a ray that goes up to 10 o'clock and a ray that goes up to 2 o'clock. Angle 2 has a ray that goes to 8 o'clock and 4 o'clock. Neither one of those they share. Just because they're connected, just because 4 o'clock is connected to 10 o'clock, that's a line, not a ray.
They only share a vertex.
They only share a vertex. Correct. So don't get. So I think what's happening is you're getting fooled that you're thinking that it's the line that they share.
Yeah,
they
that's
cannot
right.
share a line. They need to share a ray, and the ray stops at the vertex. So the ray to 10 o'clock and the ray to 2 o'clock, those are two separate rays. The ray to 8 o'clock and the ray to 4 o'clock are two separate rays. None of those are the same. Okay?
Yeah.
All right. So they share the vertex but no common ray. So angle 1 and angle 2 are not adjacent. They're actually called vertical angles. They're opposite each other. Okay? If they labeled the angle, so if you're at angle 1 up at the top and you went slightly to the right past that ray, and they named that angle, so they named the angle that has the ray from 2 o'clock and 4 o'clock. If they named that angle, then that's an adjacent and linear pair. So if you go from the vertex to 2 o'clock, back to the vertex, and the vertex to 4 o'clock, that angle is a linear pair with angle 1. It's also a linear pair with angle 2. It's also adjacent, right?
Yeah.
But they did not name those two angles, either one of those. So we have nothing going on here other than their vertical angles, which we're going to talk about in a couple sections here in the future. Okay? All right. Number 13 at the bottom of the page, Bryant.
Okay.
So we have 3 rays, angle 1, angle 2. Are they adjacent, linear, neither, both?
I'm going to say adjacent.
Correct. They are adjacent because they share a vertex and they share a common ray. But notice the non-common sides. Those do not extend in linear opposite directions. They kind of feel like they go in opposite directions because technically they do, but not in exact opposite directions to form a line. They're slightly bent. You really have to feel that nuance that they're slightly bent. Okay? So that's not a linear pair with that slight bend. So you did a good job. They're just adjacent. All right? The trick of this stuff is really it's very simple information. Where you need to work and practice is really carefully reading these drawings and really thinking about putting that Euclidean geometry brain on and thinking about the checklist of the rules and the definition. And your checklist of your definition for an adjacent angle is common vertex, common ray. Your checklist for a linear pair is common vertex, common ray, and then the non-common sides extend in opposite directions to form a line. All right? So they have to be an adjacent pair and forming this line. All right, you 1, 2, 3. I got to count this morning. You 3. Let's get out volume 9. And it's
I'm going to go get mine. I'll be right back.
It's immediately to your right, Abby. And we're going to be on page 116. and it is it's called Complementary and Supplementary Angles, and you probably have learned this information in pre-algebra and algebra days, so it'll be a nice review. But again, it's going to be a review where we practice reading those tactiles. That's where the vast majority of the work in geometry is reading those drawings, and especially when you have to read them tactily.
One you can take that off of that bunch, you know. Take this off. There, leave it.
I'm here.
Oh, no, she's just waiting for you to get ready.
We're waiting for, Bryant had to go get a book.
116?
Yeah.
Okay.
Oh, great.
I'm going to get the page on. I'm going to turn the page in my book too so I can see your tactiles. All right, page 116. Let us know when you're back, Bryant. Are we on here? Oh, what did I grab? I grabbed volume 8. I need volume 9. There it is. That's not too bad of a tactile. I think we'll be able to make our way through. We're going to be on 116A.
You can just put that there. Just set it up here on the scanner.
Down to the right.
Yep.
Yeah.
That's good.
Are we on?
All right. Hello, Bryant. We are on page A116.
Okay.
A116. And they have a tactile in the middle of the page, and they've done a pretty decent job with this tactile. What the background of the tactile is, there's some little squiggly lines that you can kind of follow. They're doing the outline of a maple leaf, I think, or an oak leaf. Let me see if they even say what it is. No, they don't. Looks kind of maple-ish to me. So it's the outline of a maple leaf that's fallen from a tree in the fall, you know, when they turn different colors. In your book, this particular one is really dark orange.
Oh, good.
Yeah. And then what they're doing is they're tracing over with arrows the veins of the leaf, the little. So when it comes from the stem, there's these little veins that come out to the tips of the leaves, and there's some main veins, and then it has little veins that'll go off to the sides. It kind of feeds the leaf with the energy and stuff. And so they drew arrows through those main veins that then created angles, didn't it? You have a vertex at the back end of your leaf on the right side, and then if you go up from that vertex till about 11 o'clock, you have one arrow. And you go back to the vertex and go back through about 9 o'clock. You have another arrow. And you go back to the vertex and go through about 7 o'clock, and you have another arrow. And so those arrows are rays, aren't they? They're just big fat rays. And so we have a common vertex, and we have a common ray, don't we? And
Yep.
they've created an angle 1 in the top position. That would be from our 11 o'clock to 9 o'clock. That's angle 1. And then from 9 o'clock to 7 o'clock, that's angle 2, right? And they're saying that kind of in nature, now that what's a bummer is that in your tactile, it doesn't show that this is a right angle. They didn't put the box in it to show that this is a right angle. But it's saying that angles are all around us, even in nature. And the veins of a maple leaf show a pair of complementary angles, where the measure, it says below, underneath your drawing, the measure of angle 1 plus the measure of angle 2 equals 90 degrees. Remember, to indicate measure of angle, you use right below your drawing, Abby. You use a little m and your ED and O, and then they do number 1, and then they add it, and they use the m and then the ED and the O again, and then they use the number 2, and it equals, and then number 90, okay? 90 degrees.
What is complementary?
So they're called complementary. Complementary. When you have two angles that you put together to equal 90 degrees, they're complementary. And if you turn the page, that's the next, that's the definition of complementary angles. So you have two tactiles in the middle of the page. We have one on the left that has a vertex B and heading up into about the 1 o'clock position through point A. That's your ray there, BA. And then you have ray BC going through about 3 o'clock. And that's forming an angle, and they're labeling it. What are they labeling it? 40 degrees? Yeah, 40 degrees. There's your degree symbol also. That's good to practice that degree symbol. Which is, what is that degree symbol? Is 4, 5, and then 4, 6, and then your 1, 6, right?
Yeah.
Superscript. What you're superscripting is this little teeny tiny 0 in print, or a little teeny tiny O in print. That's how it gets written in print. And then they have an angle to the right. It's kind of upside down, I guess, so to speak, right? We have a vertex at the top labeled vertex E. And then if you go down from vertex E through about 7 o'clock, it goes through point D. So you have ray ED. And then if you go through back to E and go down through about 5 o'clock, you go through point F. So you have ray EF. Those two rays form an angle, and then in the midst of that angle, they're saying it's 50 degrees, right?
Yep.
Right, and then the definition, when we read the fancy words up at the top, definition of complementary angles, in words, two angles are complementary if and only if, by conditional statement, right, if and only if, the sum of their degree measures is 90. Sum of their degree measures. So they don't have to be side by side. They can be floating out in space like this model, and you would be able to say that angle ABC or CBA is complementary to angle DEF or FED. Or you would be able to write it as an expression. You could say the measure, and that's down below the drawing at the very bottom of the page. It says symbols. You could say the measure of angle ABC plus the measure of angle DEF equals 90 degrees. Notice all that nemeth, right?
Yeah.
Do your little measure angle sign, M and then ED and OW. And then they do capital A, capital B, capital C, and then your plus, and then the measure the angle again, and then capital D, capital E, capital F equals 90, all right? Always, always, always. Two angles that equal 90 degrees, if their measures equal 90 degrees, those angles are called complementary. So what's going to happen when you practice this kind of stuff is most likely they're going to say, two angles are complementary. If angle ABC is 20 degrees, what is the measure of the complement to this angle? Something like that. They're going to, and you would have to subtract, right? You'd have to go 90 minus 20 is 70 and say that, okay? All right, so let's read some more. Turn the page. We have some reading to do. Talks about if two angles are complementary, each angle is a complement of the other. For example, angle ABC is the complement of angle DEF, and angle DEF is the complement of angle ABC. Complementary angles do not have to have a common side or even the same vertex. Some examples of complementary angles are shown. So in fancy math words, they just said what I said a few minutes ago, right? I said, notice that they can be floating out in space. They don't have to be adjacent angles. They don't have to share a common side or a vertex. They can just be angles that are hanging out. And they are complements to each other. One is to the other as the other is to the other, all right? If one is 40, the other is 50. If one is 50, the other is 40. They're just complements to each other. And that's language you want to memorize, is if you had to find the complement to an angle, if the angle is 40 degrees, then you would say the complement to that 40-degree angle is an angle that would be 50 degrees, all right? They give some examples. There's two angles on this particular page. The one on the left has vertex G. It's, what is that, 55 degrees?
Yep.
So then you're going to have one at the right. You could put your math brains on and already probably figure out what's the one at the right going to be without even reading it.
Mm-hmm.
What would be the complement to 55 degrees?
30.
35, yep.
45.
35. 55 and 35, yeah. 55 and 35. So if you go over and look at the angle on the right, it has a vertex J. It's a 35-degree angle. They're labeling the 35 degrees on the outside of the angle, and then they have a little, like slightly little dashy line that points into the interior of the angle to help you there. All right, you see it? Okay, so angle G and angle J says at the very bottom of your page, the measure of angle G and the measure of angle J add up to 90 degrees. All right? You turn the page, they give another example at the very top of the page, D116. You got a bunch of information going on this little drawing. You have a vertex Q. All right, and then from Q you go straight up to 12 o'clock through P. So you have ray QP. Go back to Q. Notice there's a square hanging out in the interior. What does that square mean? You feel a square on the interior of an angle. What does that mean?
That's 90 degree what?
Anyone? What does it mean when we have a square on the interior of our angle?
That it's a right angle.
It's a right angle, and a right angle is how many degrees?
90.
90. All right, so immediately your brain should turn on and go, oh, 90 degrees, I could have a complementary situation going on here. We have another ray going from P through about, the 2 o'clock position through R, PR, and then through about the 3 o'clock position through PS. And they've labeled just below the S and above that PS ray, they've labeled the measure of the interior of that angle, RQS. They've labeled it, what, 220 degrees? Did I read that right? Got to read my Braille.
Yeah.
20 degrees. All right, you're my editors here. You read this better than I do. All right, and then angle PQR or RQP, the adjacent angle to this angle is also its complement, and so it is labeled 70 degrees, right? Because 70 plus 20 is 90. It better be. They told us this is a 90-degree angle, right?
Yeah.
And it says below those two drawings that the measure of angle PQR plus the measure of angle RQS is 90 degrees. All right? How about the next drawing? I just had an idea. I need to be drawing on these things for my visual learners. So the next drawing, they have a vertex, what is that, Z?
Yeah.
Read that right? Vertex Z. And if you go straight up from vertex 3, you go through point X. And then you go back to Z, and you can go through about the 9 o'clock position through point V.
You know what? Oh.
Yeah? Then you go back to Z and go through about the 10 o'clock position through point R. No, W. That's my dyslexia in Braille. W. And then we go back to Z and we go through about the 2 o'clock position and we go through point Y. Yeah, did I get them all?
Yeah.
Okay. Now we've got some angles here that they're labeling, and they're labeling angle VZW, which is the furthest angle to the left. So find V, go back to Z, and then find W at 10 o'clock. That angle, they're labeling, what are they labeling that? 30 degrees? 30 degrees. Then they have a label to the right with a slight little arrowy marker pointing to the interior of XZY or YZX. And what are they saying that is? 60 degrees. 60 degrees. So those two angles, the 60 degrees and the 30 degrees, they are complementary. Notice that they do not share a common ray. They don't have to. They don't have to be adjacent to be complementary.
So
you can that angle right there you can leave out. We don't care, right? They're just saying that the XZY or YZX plus VZW or WZV, they are complements to each other. They're complementary angles. This is an example of the angles can share a vertex, but they don't have to share a common side. They just have to add up to 90. Oh, not 89, 90. Okay? All right. Let's turn the page, and what do we got? Okay. At the very top of the page, before we have a page break, it's telling us if the sum of the measure of two angles is 180 degrees, they form a special pair of angles called supplementary angles. Supplementary angles, yes. All right, then there's a page break, and we get our official definition of supplementary angles. Here we are thinking as Euclidean geometrists with all these words. So just as the complementary definition, now we have a definition for supplementary. It says two angles are supplementary if and only if the sum of their degree measures is 180. All right, so complementary is 90, supplementary is 180. Now, remind students how you can remember that. And Jessica, I think, said this the other day, how she remembers it also. C comes before S in the alphabet, right? Complementary starts with a C. Supplementary starts with an S. C comes before S in the alphabet. 90 comes before 180, right? So that's how you can remember it. Complementary is 90. Supplementary is 180 because C comes before S and 90 comes before 180. Little memory trick. Now they have two tactile drawings towards the base of your page. They have one on the left with a vertex Z again, right? Did I get that? No, is that a Z? Yeah, an N. Uh-oh. See? My Braille dyslexia. I get myself all turned around. That's why you got to help me. All right, and it goes through point P. And then back to N, and we go through immediately to the right or left through 9 o'clock, and we go through point M.
Yep.
All right, and they're saying how many degrees is that? 45? 45 degrees. All right, we got one. Now, if we just learned that two angles that add together are 180, we could probably put our brains on and figure out what the next angle is going to be before we even look at it, right?
135.
135. Yeah, let's go to the right and take a look. So we have a tactile to the right with a vertex S. And if we go up through about the 10 o'clock position, you go through point R. We have SR, ray SR. Go back to your vertex S and go through about 3 o'clock. And we go through point T. We have ray ST. And in the midst of angle RST or angle TSR, or we could just call this angle S, couldn't we? Because it only shares that one it only has one vertex. Two rays, so one vertex. So sure enough, have 135 degrees, right?
Yep.
And we better, if they're going to be supplements to each other. 135 plus 45 is 180. So in symbols, down below at the bottom of the page, it tells you that the measure of angle MNP plus the measure of angle RST equals 180 degrees. All right?
Yeah.
So the measure, I'm going to write this out in print for my print users. The measure of angle MNP plus the measure of angle RST has to equal 180 degrees. All right. Phew. Not too bad. The math isn't too bad, is it?
No.
Then they again remind you on the next page, just as they did with the complementary angles, they say similar things about the supplementary angles. They say if two angles are supplementary, each angle is a supplement of the other. For example, angle MNP is the supplement of angle RST, and we could say it in reverse. Angle RST is the supplement of angle MNP. Like complementary angles, supplementary angles do not need to have a common side or the same vertex. The figures below are examples of supplementary angles. So they have two angles on this page, fairly decent sized one. One is on the left and slightly below one that's on the right. The one on the left has vertex B, and they don't name any other points. They just have two rays extending from vertex B, one into about the 10 o'clock position and one about the 7 o'clock position. And in the midst of it, they say that's what, 55 degrees?
Yeah.
All right. And then you have an angle slightly up above to the right that has a vertex E. And they have two rays, one extending through 9 o'clock position and one through about the 5 o'clock position. And then the interior of that angle, how many degrees is that? 125. I hope so, because 125 plus 55 should equal what? 180. So those are supplementary angles. So angle B is a supplement to angle E. Angle E is a supplement to angle B. All right, turn the page. Oh, now we have something that you recognize. We got stuff going on here on this drawing that you just learned, didn't you? So we have vertex K. Vertex K, find that. Immediately go to the left through the 9 o'clock position through point H. All right, then go back to K and go up through about the 1 o'clock position through point, is that E or I?
I.
Thank you. See, there's my Braille dyslexia.
What is here? This one is talking
All right, and then go back to K, find K, and go up through, think about your clock, go up through the 1 o'clock position through point I. Okay, there you go. Go back to K and go immediately through the 3 o'clock position through point J. All right, and then they've labeled the interior of our angles. So if we go back to K, we have an angle HKI. That's the angle on the left. They have the interior of the interior of that angle labeled, what is it, 110?
Yeah.
All right. And then you go from IKJ or JKI, the angle on the right. That better be 70 degrees, right? Okay, so those two together combined for 180, they're supplementary angles. What they're also, it doesn't have to be this way, but this is very interesting to note for a future lesson. This set of angles, what are they also called? Angle HKI and IKJ, what else are they called? They're supplementary, but what are they also?
Adjacent.
They're also adjacent because they have a common vertex and a common side, that ray KI, and they are also called what else?
Linear.
Yes. We got the trifecta going on here, don't we? We've got supplementary angles, we've got a linear pair, and they're adjacent. That's very important to remember because if you put your brains on, going from point J through point K to point H, that's a line, isn't it? And that angle, if we arced it from, if we kind of went in an arcing motion from J to H, we did a little arcing motion, a half circle motion, that's 180 degrees, isn't it? It's half of a circle. Super important to kind of put that in your head for later. All right? Okay, but remember, supplementary angles don't have to be adjacent or linear. So the next drawing shows that. Oh, what a mess the next drawing is. All right. We've got a spider web going on here, practically. All right, we've got all sorts of rays. It looks like 1, 2, 3, 4, 5 rays. We've got a vertex point right in the middle, and it looks like they're labeling that a V, just slightly above it. And off of V, we have a bunch of rays. So we'll start at about the 8 o'clock position and go clockwise. So we go from V through point Q. We have ray VQ, and go back to V and go through just above 9 o'clock, almost 10 o'clock, and go through point R, so VR, then go back to V, and go up through about the 1 o'clock position, and you're going to go through a ray, or a point S. Yeah?
Yeah.
All right, I'm doing okay. Do I get extra bonus points today for my Braille reading?
Sure.
Oh, thank you, Stormy. Abby's up here like, no, you don't. So mean. She wants to be a teacher. Her kids are not going to like her.
No, I'm going to be nice.
Oh, you're going to be nice to them. You're just not nice to me.
Yeah.
Yui.
Yeah.
All right, go back to V and go just slightly, between 2 and 3 o'clock. You're going to go through point T. So you got a ray VT. And then go back to V and go down through about 4 o'clock or so through point U. We got ray VU. So there's all our rays. Now the angle that they're labeling the measure on, they're labeling the big, huge, obtuse angle, right? We should be practicing our obtuse and acute definitions. QVU, or UVQ. It's the big fat one at the bottom. They've got a label in the midst of it, and they're labeling it 140 degrees.
Yeah.
Did I get that right?
Yep.
All right. And then they're labeling a smaller angle, SVT. So S is up at about the 1 o'clock position, SVT. And they have a slight little kind of light arrowy line that they're trying to point to the measurement, which they're labeling 40 degrees, okay? And they're showing you that SVT and QVU are supplements. They don't have to touch. They do share a vertex, but they don't have to. But because their measurements add up to 180 degrees, you can say that they supplement each other. They're supplementary angles, okay? That's a good example of non-adjacent angles. Creating supplements, okay? And in symbols just below it, they tell you the measure of QVU plus the measure of SVT equals 180, all right? What do you think? You getting this so far?
Yeah.
Yep, I think so. And let's see. The bell's going to ring, so let's just take a breather, and tomorrow we'll finish up where we have to name adjacent complementary angles and non-adjacent supplementary angles. And then we need to do some algebra with all of this stuff and also do some proof writing, okay? So that's going to take us some time tomorrow to do, and we want to take our time doing that because we really want to develop those skills. It's pretty simple math to add up to get to 90, to add up to get to 180. What we want to do is really put our brains on about why it's happening and how we can prove it happens and reading these graphics very, very carefully. All right? So we'll stop there. I'm going to give you a reprieve on homework tonight. Okay? But maybe if you could at least memorize in your brain that complementary is 90 and supplementary is 180, that would make me very happy tomorrow. All right?
Yeah.
All right. That's all I have for today.
Okay.
That's it.
I
The
thought
bell's
you
gonna
were doing
ring.
homework.
No homework. I said I'm gonna give you a reprieve, Abby. Reprieve means I'm gonna give you a break. I'm gonna give you the night off. But I want you to memorize that complementary is 90 and supplementary is 180. C comes before S in the alphabet. 90 comes before 180, right? Okay.
Hmm.
Have a good day. We'll see you tomorrow.
Bye.